why the command line, why use them. And in this video, we'll delve head first into the command line. Well, we won't really delve too deep. It will be just a quick plunge. Because, as I mentioned in the introduction to this series, my idea here is to do a speed run where we cover the basics that you need to install something and to run something else. I'll give some examples, and all this should empower you to go on and find the rest for yourself. Pique your interest, spark the motivation. Anyway, the two main topics in this video are some examples on the command line and the terminology that sort of explains what's going on here. Okay, so over here I have a window, and in this window I'm running what's called a terminal emulator. The terminal emulator is basically anything that has text. To put it simply, and within this terminal we're running what's called a shell. A shell is where you put in your commands. So list, and then it does something. You run Python, it runs Python. Now, why do we have this distinction between the terminal emulator or the shell? Typically, people just say the terminal for both. To be clear. But the idea is you can have something other than the shell, like for example, like a file manager, file browser running, or a music player, or something like what was the other example? Sort of an interface that guides you to creating a new network connection. So it's all like in a way like the 80s text games, RPGs in text, that they're very powerful, as you'll soon see. Okay, so let's go over some commands now. Now ls or list. Now you will notice almost all of the commands are some mnemonics, at least the basic ones are. So ls list, and that lists the contents of a directory. Now we try to make also, I should say immediately, this text interface, the shell or whatever else, somehow more usable. I mean, there's no reason, reading so much is already difficult. There's no reason to make it more difficult, or rather, I should say, there's incentive to make it easier. So, in my case here, the directories are colored in blue, and the files are in this orange, or whatever this is, khaki, I don't know. And there's some other things. So if you put in a command that's wrong, it's going to be in red or green if it's correct. Now this comes in. This is sort of the syntax highlighting package for ZSH. That's the shell that I'm using here. If you use the Docker image, which installs the software stack I'm introducing in the third part of this tutorial series, then you'll have this pre-installed already. But just know this, it's not there by default. I don't know why it's not the default, but Bash is instead. I mean, it has some of these features, but not all of them. Okay, so listing. Another thing that sort of helps us when using the command line interface is the fact that we don't have to type everything out. If you hit tab, there's what's called the tab completion. So now it's going to offer me, some options of what I wanna list. The same works for the commands themselves, or some advanced sort of, if they're commands that are comprised of many parts. So systemctl has a bunch of these things that you can do that sort of interfaces directly to. It's like a bit low interface to some low-level things. We don't need it, but just good to know that hitting tab on commands is a good idea. Saves you a lot of time. It's just nice. Okay. Then the next thing is to, now that we have some directories, we can cd or change directory into something else. And now I'm in the directory called books. I can list see what's here. If it's a book, I can open the book with a PDF reader, a paper, whatever. We're listing things, we're changing directories. Let's connect this to an idea I introduced in the previous video, which is that everything is a file. So, and everything is a text file, in fact. Well, these files have to exist somewhere. The computer needs to know, the operating system, I guess, needs to know where they're stored. And here we come to the idea of a path. So every single in Linux, every single file is somewhere in the file system, where all the files live in one big tree. And this is organized in the following way. You have this initial directory called root, denoted by a slash, and then there's other directories in it, and there's a tree where every file lives. Now let's go back to here. If I type in pwd or print working directory, I will get the whole path from this root thing up to where I'm now, the directory where I'm in. And if I have some file here, let's just the whole path would be home, my username, this directory, and then okay, let's choose like some nice PDF. You probably noticed, like in this, there's like the absolute path does not. So if I do ls and then some directory, right? Okay, none of these are the directories. There's a space in between the command and the input, and this, so shells like spaces, and they denote different items via spaces. But what happens if the name of the file has a space? Then you need to do a backslash before a space, or the escape character, which basically tells it, okay, don't treat this as something in between arguments. Okay, so if stuff breaks randomly, it's this could be one of the reasons. Probably the easiest way to get rid of this is to put everything in what are they called? Quotation marks. Yes. Okay, and there's another thing called a relative path, which is just a shortened version of the absolute path. So dot is the previous directory, can move to the previous directory, and dot is the current directory. The dot is relevant for when you have, so your shell will expand the dot into something else, because some programs don't do it themselves. When you're running, if you give a program the absolute path, so the whole thing from root, it's gonna know where the thing is. Yeah, everything certainly works with absolute paths. Some things don't. So you need to expand them out. And yeah, you can type in the whole path to get there. Okay, so that's sort of on paths, a bit of the shell syntax and so on. Okay, this would be a good point to also go over how to create files, manage files. Now that we know where they are, it's good to do something with them. I will be doing this in the tmp directory. The tmp is deleted after you shut off your computer. It's like basically RAM, but it's on hard disk, not in RAM. Anyway, we create a file with the command touch, and then we can say something like script.py, and now I can open this file and do whatever with that. You can remove a file with the rm command. Now it's not here anymore. Another thing you might want to do is to create a directory. So let's do that. Now it's here. Okay, and then we can add something over here. Now, if you want to remove a directory, rm won't work, as it will say, I can't remove it because it's a directory. But then you might want to do rmdir, remove a directory, but now it says, I can't remove it because it's empty. So how do you delete a directory and everything in it? Use the recursive flag. And it even says so, remove directories and their contents recursively. So it will, if there are subfolders in it, it will open those and remove everything there. Okay. Let's do something that's interesting finally, and that would be to install a package. Now, installing things on Linux functions very differently than what it does from Windows. On Windows, you go to a web browser, to some website, you find the download button, it downloads something.exe, you click on this, and then you click on more things in the pop-up window to get it installed. That's how you install most things. On Linux, you use your distributions package manager, and I'm going to explain the words that I just said. So a distribution is a pre-packaged set of things shipped around a Linux. A Linux is a kernel. That's the sort of the core of the operating system. That's the bare minimum. These different commands that we're typing in, those are typically actually they come from GNU, which stands for GNU is not Unix. Anyway, these commands are separate from the sort of operating system itself, let's say. The window, the program that runs the window, this sort of camera interface, those are all separate things. Anyway, as I said, Linux is very customizable, and what people do is they bundle a bunch of these programs together into what's called a distribution, and then when you install a Linux, you in fact install a Linux distribution that comes with a bunch of other things. Distributions package manager. So what's a package manager? Well, that's the core of a distribution. That is the program that synchronizes your computer according to your wishes with the server of the distribution. So why do we need some distribution server? Well, the idea is it stores a lot of the packages or the programs you wanna use, and then the way you install a package is you tell your package manager to basically copy the file from your distribution's servers to your computer. And different distributions have different package managers. That's the biggest difference between them. I'm not gonna bore you with all the details. If you're interested, now you know which terms to Google. I'll just mention that in my distribution, this one's called Pacman. So just to know that like other things exist. Anyway, for this, let's go to the aforementioned virtual image with everything installed. I don't even know if I mentioned this actually, so sorry if I'm repeating myself. Please skip ahead. Yeah, for the computer, for the robot control library that I wrote a Docker package, the virtual machine thing that will install everything you need to run things from this library, the examples and so on. Anyway, that virtual machine is a Ubuntu distribution, and it has a package manager called apt. So the first thing you do when you want to install something, I mean, preferably you should know what to install. We'll install a program called htop, which is essentially like a task manager on Windows. Now, as you can see, it's not a shell, tells me that the command is not found. Okay, so if I just type in apt, it's gonna, or apt maybe help will be even, it will be the same thing. That's gonna tell me what sort of things it has, what you can do with it. So you can install packages, you can reinstall them if you want to. That's a bit complicated. Let's not get into that. You can list the packages that exist. You can list the packages that you have installed. You can remove packages and so on. So basically, almost all the everything that's remotely standard will be managed by the package manager. You always want to use your distributions package manager to install things if possible. You have at some point hundreds of different programs installed, and the people to maintain the distribution basically make sure that the different versions of things work. So if you install 5 of these packages, the 6th one ideally won't break the other 5 due to different versions, because people change the software, how different functions are called, they add stuff, they remove stuff, and you need to ensure that you have the same versions so that everything works in harmony, or just works actually. Anyway, so how do you the first thing you need to do to install is to update. So that way your local computer, your package manager, knows what's new at the server. Now let's run this, and it says, oh no, there's an error. Could not open locked file, blah blah blah, permission denied, unable to lock directory. This is key, permission denied. So now I have to introduce a new concept, which is essentially administrative rights on Linux. How do they function? So this is in a bit wider topic called permissions. So on Windows, when you install things, you at some point need to say, yes, I am sure that I want to do this. I give administrative access. Basically, the idea is we want to separate users' files from system files. Because system files typically are important and you don't want to touch them. Because most often you will just, if you don't know exactly what you're doing, you will break something. The common joke is, haha, type this into your terminal. This would delete literally every file that you have, breaking the system, obviously, in the process. So the way you would give administrative access is by pretending you're root. Root is the user, the administrative user, and here the student is your own sort of regular user that has, here I have my own files that are for my user. If I go to root and I look at all these things, they are owned by root. If I give a special addition to ls, don't want to get super distracted now, but anyway, in these columns we see who is the owner of different files, and here it's specified what you can or can't do to them. I won't get into that now, but if you do this in the in your own directory, then you can see that the owner of these files is a student. Anyway, when you install things, you will put them in the directories and that the root owns, and they will interact with other things that the root owns. You're changing the operating system itself in a way, if you consider it the bundle of the kernel and the things around it. So you need to give administrative access as the root user. Now you could, with an su or switch user command, change the root, but typically you don't want to do that, because you could accidentally forget your root, and then bad things happen basically. So what you do instead is sudo, which is execute one command as root. Okay, so getting back to where we were, we want to install something. To install something, we first need to update. You don't technically need to do it every time, but it's good practice to update. Okay, so last time when we did this, we got an error. Where was that? Okay, anyway, this ran now. There's a way I can search through this text. I just don't want to show too much things all at once. If you want to have reasons for why you should use Linux and as your daily usual operating system, there's a separate bonus video for that where I'll go over this more fancy stuff. Anyway, update done, all packages up to date. Great. Now I do sudo apt install, and the program is called hdop. So that you can check. I mean, the reasons why you would run this, I give it a yes. I do want to continue to see what processes you're running, how much CPU is being used, and what's the memory status. And you can kill the programs. you can kill the programs here as well. There's another way to do that. I won't get into it again. That's like you can, if you Google, how to kill a process, you'll find it. Okay, now kind of nothing was happening there. That's because we're in the virtual machine. If we run it on my host, here you can see FFmpeg. That's what's recording this video, running, how much sort of CPU it's using, what's the memory usage, blah blah blah. Okay. So now we've covered what a package manager is, how do you install packages. For Python, we'll come to that later. You have Python's own package manager, because Python has so many different packages that you need a separate package manager just for its purposes. I promised you that it's very easy to sort of go in to different computers. So I'll just very quickly do this as well. With a \r, I search through the commands I already put in. This is my home server. And there we go. Now I'm in the home server, and as you can see, things look not exactly the same, though very similar to what I have at home. So I, back my things up over here. Changes the colors, they stay this way. It's like whatever. And one thing I will mention as a sort of two things left to mention. Number one is Control-C. Control-C kills something that's running. So if I were to, this is Control-C. Anyway, let's go to Python, and I'll just do the most stupid thing, while true, so forever, print something. Print the letter A, let's say. Now it's gonna keep doing it and keep doing it. If I press Control-C, it will kill this program. This is not just a Python thing, this is for anything else. I just wanted to very quickly do something that's infinite and bad. This functions via signals. I'm not going to go into what signals are. Anyway, if there's something running in the terminal and you want to kill it, you can do Control-C. If it refuses to be killed, then you do a Control-D. And this is in fact going to kill the shell in the window as well in this case. Okay, so I do actually want to talk about signals, at least for a little bit, because it might be useful and very annoying to find otherwise. So I just mentioned how you can kill things with Control-C. Now we're going to do it a different way. So I'm just going to start a program here that just listens to a port. This will be actually covered in the networking tutorial if you're interested in that. But anyway, the point is I have this program running, and it could be in the background, it could be somewhere else. I just want to show how I'm gonna kill it here. So the reason why I'm referring to this as kill is because the command kill is used to send system signals. Now there's a whole lot of different signals that one can send. Basically this is just one form of inter-process communication, but let's not go into that. What I want to show you is how do you kill this program up here. So you need to know its name. With the PS you get a list of some processes that are running and their process IDs. So every process that runs needs to have its own ID. If we run something a bit more convenient, we can see graphically convenient, you can see all the processes that you have. And the point is that they have a PID, process ID. Okay, anyway, the point I want to make here is with this, you can list all of them. Okay, and then you can pipe this into grep. Grep I won't cover here because it is complicating life too much, but basically what nor piping, that's in the advanced video, but I mean, it's still basics, but anyway, you can find for a particular, you can find a string inside of this, all of this text. With the pipe, the text is transferred to the following command, as if it was written here. Okay, anyway, I know that the program is called NC. I type in NC, this is the process ID. I now use the kill command to send it this signal, and that will kill this process. So if you have something that's accidentally hanging in the background, not everything is closed, this is the 100% fault tolerant way to kill a process. It's not like, yeah, there's two signals people send for this, kill and term. Term stands for terminate. So yeah, kill is number 9. Yeah, if nothing is specified, term is sent. Term instantly vaporizes the process. Okay, there is no way for the process not to die after you send it the term signal. Something is seriously wrong if that doesn't work, in the sense of like you better reboot your computer, or the application is doing something incredibly weird. There is a way to overwrite signals, but no one should ever overwrite the term signal. Okay, so that's how you kill any old process. Okay, so I think that would be that on the commands I want to do. I will bring this sort of very cursory introduction to an end by telling you how do you, yeah, what are some of the resources you can use apart from just, Googling tutorials in the beginning. Just, give me 20 most used Linux commands. Look for stuff like this in the beginning. And then you have a command and you don't really know what to do with it or what its options are. Like I said, I think I've said before, you can do the LLS -- help to see what's out there, out of the options. But that typically just tells you, okay, you have this option and or this parameter to give, and then like one sentence about it. Sometimes this is not enough to really know what's going on. But if you do a man, then you invoke a manual, the command manual. That's, yeah, basically Linux ships with manuals on various commands. New things you install as well will very often have a manual. Not everything has a manual, but this is typically a bit, there's like at least a paragraph explaining sort of what's going on before you get into the options, and very often there are examples. These things can be incredibly long. wget is like a very, it's a command to download things on the internet, from the command line. It has a ton of options of how do you handle this or that web page, and it's extremely extensive. Typically you don't read the whole thing, it would be, you could if you really wanted to know everything it offers, but see, this thing has like 1,800 lines. Typically what you would do, hit / to search, and then you would find a keyword that you're interested in. So I don't know, if I want something with HTTP in this command, I would then hit N to find the new reference, and this way I would find the information or that, or search for example, and then I find some examples here. Okay, so man pages -- help are your always number 1 and 2 options to learn what a command does. Very often they have like a crazy amount of different options, so you don't need to know a lot of commands, but if you know a few of them well, like grep, for example, that's very powerful. There will be an additional video on how to do scripting and like showing off a bit more of the commands if you're interested. Okay, so this covers what you would do if you already know the command that you want to use. But what happens if what to do if you don't even know which command to use? Probably the first thing you want to do is Google what you actually want to do, and then see what's there. Now, in this case, don't just blindly copy paste the commands. Read them, read their man pages, try to understand what happened there. You don't have to do this every time, obviously, but it's a very good way to get up to speed with everything. It's easier to know already what to do without having to Google it, is what I mean. If you want more sort of additional information on still the basics, because I skipped almost everything, there's tons of videos on YouTube. That's how I learned most of my Linux knowledge. I did take a course as well, which helped a ton, but even while doing that course, I watched videos, because it's, I obviously believe that that's a nice way to learn things. Other than that, there's a bunch of, okay, so if you want to, if you don't know exactly what the name of the command is, you can use apropos. So let's say you just know it's mk something, then you can see what the what mks are out there. Now you can, this is piping is a bit advanced, but you can search through this if you know that it's make directory. You don't know it's mk dir, so you search for mk and then you scroll through dirs. Probably you can do propose directory, would give you something. Yeah, so I mean it's one way to relatively quickly try to find something. Other than that, my favorite page to just get up to speed with like the daily things, let's say, would be the info core utils page. So this is kind of, info is very similar to man. It just uses slightly different key bindings to go around, and it's written by GNU people. So unlike man pages, it has more of like a tutorial feel to it. So it has like some text explaining what's going on, and as you scroll, it automatically brings you to the next page. So if you go through some of these things, now of course you don't need to go to everything, but here, I mean, it's something about outputting files. How do you output only parts of files? So like my head is like for the top and things like this. You can find all the basic stuff is covered here. Okay. Then if you're the sort of person that prefers a book, I highly recommend this book, The Linux Command Line by William Schotz. It is 500 pages, but a lot of it is pictures and examples, and of course you don't need to read everything. These are textbooks, they're not novels. It's right here. I would say that up to maybe the end of chapter 7, you're already fine with most of the things you'll ever need. But of course, if you're planning on using Linux as your daily OS, then probably read the rest. Again, the text is not particularly difficult or too dense. So, and it has a bunch of examples to see, like this is an output of some file, so on. But you can, type these in as you're going along. I think it's a nice resource. I think I even found a link to this book in one of the man pages. I might be wrong there. And then finally, we have the Bible for programmatic access. Now I'm just sort of mentioning this to tell you how far the rabbit hole goes, so that you know what sort of time investment there is if you want to fully learn everything there is to learn and sort of become the Linux wizard. If you want to become a wizard, then you need a book for wizards, and that's the programming interface. So if you it explains all of the system calls that exist, and it's all of the examples and everything is in C, because the Linux has been written in C. System calls is like the parts of the OS that actually handle something that you don't ever want to think about, like hardware management. When you open a file, some part of the code needs to actually find where this file lives in memory. So when you do an open file, that would be a system call. And this book goes through all of the system calls, 1,500 pages, but by the end of this, you can write your own drivers, basically, if you went through all of this. So yeah, that's sort of the ultimate thing. Okay. There will be an additional video on how to do scripting and like showing off a bit more of the commands if you're interested. From what we've seen here, navigating against directories, knowing just what paths are, how to install things, and the fact that you should use the package manager, it's very good. You can trust the Linux distribution people a bit more than random websites. The chances that you get the virus are very small. Again, open source community, distributed development, blah blah. There's a lot of people using this stuff, and they're very particular about not getting viruses. Yes, this would be about enough of Linux, of what you need. Yeah, just to essentially, if all you want to do is write a Python script and then use that Python script, you really don't need anything more than this. You don't even need the grep. It's just sort of a nice thing to have in your arsenal. And I'm sort of advertising that you should know a bit. Well, not should, but that you could learn more. That there's something valuable there. There will be, like I said, another video with a bit more things that I'm to continue with the advertisement, with the Linux propaganda. Yeah, this is what you should know. Everything that you should know. Okay, so we've reviewed what's here. I don't think I'm missing anything. No. Okay. I hope this was useful to you. I hope you learned something.